Hi guys, today we're going to solve the system of linear equations by graphing. I have these two equations, 4x plus 2y equals 10, the first equation, and the second equation, y equals negative 5x minus 4. I'm going to solve them by graphing. So first step, I'm going to make two tables. The first table, the blue table for the first equation, and the black table for the second equation. The first table has x, y, and xy, the ordered pairs. And the second table has the same thing, xy and xy, the ordered pairs. I'm gonna pick three numbers from x-axis for x. So I can pick 0, 1, and 2. So when I graph these two equations, so this is the x-axis and this is the y-axis. So this is the xy plane. So I can pick 0, 1, 2 for both equations. So when I pick 0, I can substitute 0 in the equation. So I'm gonna have 4 times 0 plus 2y equals 10. 4 times 0 is 0 plus 2y equals 10. Then I'm gonna get 2y equals 10. Divide both sides by 2. So I get y equals 5. So the first ordered pairs is 0 for x and 5 for y. So it's 0, 5. I can name it as A. When x equals 1, I'm going to substitute 1 in the equation. So I'm going to have 4 times 1 plus 2y equals 10. 4 times 1 is 4 plus 2y equals 10. I'm going to get rid from 4, so add negative 4 to both sides. Cancel out, 2y equals 6. Divide both sides by 2, y equals 3. So the first number is 1, the second number is 3, which is the ordered pair is going to be 1, 3, and I'm going to name it B. For the third number, 2, I'm going to substitute it in the equation. 4 times 2 plus 2y equals 10, which is 8 plus 2y equals 10. Negative 8 to both sides. 2y equals 2. Divide both sides by 2. So y equals 1. The third ordered pairs is 2, 1. I'm going to call it as C. I'm going to do the same thing for the second equation. For x, I'm going to pick 0 and substitute it in the equation. So I'm going to have y equals negative 5 times 0 minus 4, which equals 0 minus 4. So 0, like it means nothing. So I'm going to have y equals negative 4. So the first ordered pair is going to be 0, negative 4. And I can name it D. Then I'm going to take 1, x equals 1, substitute it in the equation. Y equals negative 5 times 1 minus 4, which equals negative 5 minus 4. And it's going to be negative 9. So the second ordered pairs is 1, negative 9, and I'm going to call it E. Then I'm going to pick 2. So x equals 2. I'm going to substitute it in the equation. So I have y equals negative 5 times 2. I always put parentheses. minus 4, because I have to organize my work, equals negative 5 times 2 is negative 10 minus 4, which equals negative 14. So the third order pair is going to be 2, negative 14. And I'm going to call it F. Now I'm done. So I can graph A, B, C, these three ordered pairs in the XY plane. And the same thing I can do for the second equation, D, E, F. I can graph it in the same XY plane. So right here, I have this XY plane. So I graphed ABC right here, and DEF, D 0, negative 4, E 0, negative 9, F 0, negative 14, A 0, 5, B 1, 3, C 1, 2, 1. This is 3. That's 2. And when I graph it, I find that these two lines, they both intersect in one point, which is, if I figure out this negative 3 and this one 11. So the solution will be negative 3 and 11. So this ordered pairs is the solution for this system of equations. If I want to check, I'm going to pick any one of them. So I picked the first one. So the first one is 4x plus 2y. Then 4, I'm going to pick negative 3 for x. So 4 times negative 3 plus 2 times 11, because y equals 11. 4 times negative 3 is negative 12 plus 22. When I add them, I'm going to subtract because they have different signs. Subtract and keep the sign for the large number. So I got 10, which equals 10, the right side for the equation. It means this solution is correct.